Good night. So this will be a microscopic examination of 3 slides. Hopefully we'll do it quickly because we are not done. It's like it's in the middle of electrolysis. Let's take a minute to see what we have here. So there is like, it's breathing, like, like, you see that it's like, it seems that, that the current is kind of like, pulsating. And this is something that I've seen, especially with strongest transformers, since long ago. And I've read the question of why it happens, and I didn't get any answer. So if there is like a chemist or a physicist like in the audience, I would like to know why do you see that, like saying like the breathing pattern with electrolysis. We've added quite a bit of salt, with a little bit of iodine, and that's it. That's about it. We did not add, of course, and we have added water, salt water from the Mediterranean. Just, because it was very dry after, so I wanted like to actually have like, so there's a question like, the electrolysis itself, like H2O to H2O to, is it like something that, actually helps us, or bothers us, or is this essential? In the past I said that it seemed to me that like, that it shouldn't be like something that is particularly helpful for the process. He said that one of the most, interesting, successful experiences that I've ever had was a small glass electrolysis that was, and I've created worms, like living worms inside of it, and this was almost completely solid. So there was no electrolysis, but it was, with 2 electrodes, and it was certainly there was kind of like, worms can be created without electrolysis or other kind of energizing the neurons, but it's much less dependable. In any way, I should say that this is still ongoing questions that that I should answer because it's pertinent to the process of electrolysis, which is very important. Still, we should remind you that there is also the process of heat or crucible. This is like by far less, I would say people around who don't seem to like it. I wonder why. But there are ways to do it that are less offensive than others, and because we will need to use it later. Not later today, but later, as part of this experiment. And maybe I'll use the less obtrusive ways. Also, should be said that something that I've never done is using sir lachatz, like pressure cooker. This is, I think, immensely interesting, like course of study that I've never done because I don't have pressure cooker, and it seemed to me dangerous. Like even if I had it, I couldn't use it in the hostel. But now, I certainly can use it. I think that in the storage, like in Holon, and I actually have a pressure cooker, if I remember correctly. So maybe this Thursday, when I'll take my stuff, I'll actually have a pressure cooker, and this will allow us all sort of nice stuff. Just with regard to the crucible, why it's needed, I intend to create a trained bacteria ex nihilo. Like from ex nihilo as opposed to ex vivo, without existing trained bacteria. And then to show you how it's done, it's pretty complicated, but I know how it's done because I've done it several times. And this is best done in the crucible, but you can also do it using electrolysis. But the crucible is great for that because the trained bacteria is known to be a demon, what I call it demon, or in plain words, extremophile. That it likes very hot temperatures, and it's created in hot temperatures. So I intend to do it and to enlarge it using the mutation, capabilities of neos. So you create like a monster trained bacteria. And I've done so several times in the past. It's not this. All of it will not be new, actually. And then my intention is to pit it against the neos, but with the symbol of killing the trained bacteria, and show you how they kill it on a microscopic slide. Maybe just without. Just by just putting the slide to rest for a week and show you the progress, Or if we manage to actually do slide energizing as part of the process, the ongoing process, this would be amazing. Like, I mean, maybe I jumped too high, maybe kind of like I fantasize, but think that, I mean, we're still not there, but my kind of, objective is to be able to energize Neros on the slide. Of course, I've never done so, but if it's done, of course, without a doubt, they will be ferocious, like, I mean, in whatever they do. And, I mean, yes, I can pit them against, East, like that thing, and maybe I'll do it even today, we'll see, tonight, but I mean, it's nice, but it's not that impressive. I mean, robots against the East, I mean, okay, but robots against the trained bacteria and the monastrous one is, that is something that is much more impressive, certainly because my audiences have learned to know, they have all sorts of like health concerns regarding the trained bacteria. It's like a problem for them. It hinders their sex life, it hinders their culinary efforts, as I understand. So it might be beneficial to see the Neros cracking, using the samurai sword to chop the material to shawarma. And if we can do it energized, I mean, it will be like in fast forward, from hell, which is great because, but even without it, it will be interesting actually. I mean, without energizing, just by putting it on a slide and let it roll. Using the symbolism of cake healing the trained bacteria. Now, with regard to what we have here, so I try not to add too much material because I should remind you, I mean, this should be the basis of the DC over R, which requires relatively many Neros that are relative, which means they are created together in a little bit of mixture. That's why I did not add P, for example, or any other stuff, just a little bit of water, Mediterranean water, because, it was so dry. So, probably what we're going to do now is, so I've taken 3 samples now, actually. One is just my P, because yesterday or the day before I had we taken a big sample, but it was like, they didn't have slides, so I wasn't even able to see anything. So just P with colored, all of it is colored with EOS and Y. So a little bit of P, just for curiosity. I would have taken semen as well, but actually, I need to be in the mood for that. I already, taken 2 samples today, in 2 separate occasions, but I didn't put it on a slide. It was just, it was discarded, like, with all, the laboratory, settings, and sometimes, things kind of like are lost, but, yes, so if I'll be in the mood for a third time, maybe this time I'll remember to, properly put it on a slide. יש איזה מישהי באינסטגרם ישראלית, יובל משהו, לוי אולי. צעירה, בתקופתי לא היו כאלה בישראל, זה השפעות נראה לי אמריקאיות, או אולי לא יודע. אולי השפעות אמריקאיות, אולי לא יודע. מאוד מעניין. יובל לוי, יובל 65, משהו כזה. מה שמעניין זה שהיא ישראלית, כן? תראו את הגלידה פה, זה מלח גס עם פולידין, שזה, like it's like rough salt with polyidine, which is like 10% iodine solution. So what we'll do now is, and then I've taken 2 more samples from the vicinity of the 2 electrodes, respectively, or poles, better to say. And this is our nice, ad hoc, adjustment of the symbolic language. You also see the black, and I've used gouache because somebody stole all my acrylics and oil painting. This is actually a shame because it cost thousands of shekels, and they also stole my brushes, and I don't have the money for that, and I cannot paint now, which is amazingly cool. Anyway, I still have gouache of my daughter, so I use, black gouache to paint it black, like all this construction. And now set it back here. Okay, for now, maybe I'll try to use another. Maybe I'll use later another transformer that I have, which is also pretty strong. This one is 19 volt, 4.74 ampere, which is the strongest, I think, combination that I've had until now. Pretty strong. This one, no, this one is for the monitor. I had another one which is pretty strong and already prepared, like, in the, like, which means that I used it, like, maybe more than a year ago in the first stage of the house arrest. And this one is not that strong, but should be pretty strong, not that strong. Where was it? Here, this one. So this one is LG 12 volts, 3 ampere, which is also pretty strong. And the nice thing is it's already prepared, to mention that I already used it for electrolysis and stuff. So maybe you use it instead of this one, because this one I need for the computer, and it's also kind of like an objective to have a desktop computer. Depends on what we're going to see now in the sample. Probably what we'll do is that I'll take a mix. I'll mix everything, maybe add something, maybe a little bit sodium bicarbonate. We'll see, and keep it like, and maybe clean the screws, and then reconnect it and keep it again working. Depends on what we see now. Depends on the result. Hopefully, good, like, interesting result, and keep it working for some more of the electrolysis. So let's start the microscopic show. Now it should be said that I've tested volts and amperes on this circle, and I received, so it's always moving. Perhaps it's always like that. That is always kind of fluctuating. I don't know. I honestly, I admit I don't have experience with this kind of meters. I see fluctuations, but in general, it's actually pretty consistent. It shows something like 20 volts and 4 amperes, which is pretty close to the specification of the manufacturer. It surprised me, but it was pretty consistent. Like, even though fluctuation, but pretty consistent. Of course, it means that this is actually, with this regard to the fluctuations, it means that this is very conductive material. Like the mixture, which makes sense because I've added so much salt, like rock salt, and also ionized water. Water from the Mediterranean. So it actually makes sense that it's. Let's see. What kind of measures we'll get later when we switch to electrolysis inside of this stuff. So I'll make it short because I consider it intermediate, analysis, not like final process. So we don't need too much, getting too deeply inside the results. although we said it, I've had a very little, advancement with using this thing as kind of like a improvised petri dish. The problem is actually not with the optics per se, but with the fact that you cannot place like very thin layer on the stuff. So we need something better than that. But actually, I'm kind of like excited towards, maybe conducting this on petri dishes under the microscope, or other kind of like energized thing like this over here or thing like that, because this seems to be much safer than with regard to the spillage than slide. And of course, you can put like paper clips to do like advanced more kind of I would say safer and predictable type of electrolysis. The problem with petri dishes is that you don't put a cover on it, so it's just too much material. It's difficult to actually see something under the microscope. But we are advancing in this front as well. We don't see actually at all, and I'm afraid. I just, I swept everything with with like toilet paper, because I like added like I cleaned it with toilet paper after it was prepared, because it was about to spill, and like I think that everything was just all the material was just went through the toilet paper, which is a bummer. Sometimes it happens that you don't see anything in the P. In the semen, it never happens, but in the P, yes, sometimes you don't see it. Like, because, maybe there are tiny ones, but not the size that we search for, not the bigger ones. So in order to understand what happened, what we'll do now is we will very quickly just take another piece. I mean, you know, from the glass, another piece sample. Try to understand what actually happened. So just a second. Just a second. Okay. Okay, let's quickly take a look. I've just, added the drop of the blue, the methylene blue. We've seen one clearly Nero, but I mean impressive one, but just one. So sometimes it likes that repeat that you don't see much. Again, remember these are very big ones that are not very common, like in P. Like it's not like the Siemens that's always like you see very big ones. The P is much less dense with very big ones. Probably many more like in the smaller Very nice. So okay, there is more than one, of course. So we see quite a bit actually. Okay, so this is actually indicative of P. I mean, that's how P looks. You see, I mean, they are pretty big. I mean, again, this is 64 magnification. So this magnification is, again, they are huge compared to what you are used to. I mean, this is 160 magnification, but it's not like as dense as what you can expect from the Siemens. But this is natural. I think what happened in the previous slide is that it's either that the red stain just obscured the many places too much, or just because I cleaned it using the toilet paper, and I think that sometimes when you use toilet paper, it's all the material kind of swept under the slide, and gets soaked with with the toilet paper. I think that's what happened, because here we see quite a bit. We see quite a bit here. It's not like one or two, but plenty. You see all over the place. Okay. Okay, so that's to be expected. Okay, so now for the probably more interesting slides, the two from here, still pulsating. I like the word pulsating. I borrowed it from all over the world, like A.G. Wells, Jeff Wayne, adaptation. So we have two slides. One is kind of like more, so there is a ton of salt that, I tried to put on the slide so it will not be like a barrier between the cover and the slide. So here, it's actually pretty, uniform, but here, there are a lot of pinches of salt or things like that created more like pools. So let's quickly watch both. This is the more kind of messy one. It's too much material, difficult to focus. This was ill prepared. I should say just too much bulky stuff. We do see Neros, of course, but too much bulky stuff. We definitely see Neros. It's nice, to see it like shining through the, the medium. Let's zoom in. This one I think is in its target position, which means like it's an open portal, I think. Yeah, that's nice. You see, it's like an open portal. It's an open portal. So not like it is an open portal. This is 160 magnification now. The problem is that this slide, yeah, it's difficult to focus because of all the salt that creates this barrier. But you do, okay, so we see plenty neos. Difficult to tell if you are already ready, for DC over air. I would say no. We want more. We want more, and so we will mix it and we will make sure that we have more neos. But before that, let's take a look at the other slide, which is more uniform and less salty. Maybe it will be more visible. Wow, very nice ones and big and beautiful. These were huge ones. So we see smaller ones. Yes, plenty smaller ones actually, which is what we wanted actually. So it's getting better. It's getting better, but we are still not there. We're still not there. We're still not there. But yes, we do see plenty smaller ones. This is 160 magnification. So it's getting better actually. It's getting better. We are advancing, towards our goals. But we're still not there yet. These are very nice fat ones. Okay, nice. Well, these are huge fellas, but we also have seen smaller ones, so it's advancing. Okay, we will continue now for more electrolysis. Mixture of a little bit of mixture, maybe add a little bit of material, and like in about maybe half an hour, or we will take additional samples. And if we are, I feel that we are kind of like we are lucky. Maybe we'll even like try to show you DC over air, and depends on the results.